Why does the division method work? So let's take a look at that briefly to see that. So if we convert the 53 into a binary number, it will have in the form of such that some coefficient 1 or 0, then 2 to the nth power, and then another coefficient and the 2 to the n minus 1 exponent, and then another 1 or 0, let's denote it as a c, and 2 to the n minus 2, and eventually you will have a c2, 2 to the 2, c1, 2 to the 1, and the c0, 2 to the 0. 2 to the 0 is a 1, so we can just ignore that. So division method is we divide the number by 2 and then take a quotient and remainder. So remember that. So divide it by 2 and then take a quotient and remainder separately. So if we divide the 53 by 2, then effectively what you do is we divide this series by 2. That's what you do. And then from algebra, we know that if you divide it by 2, that is equivalent to simply doing one by one. So if we have 2 to the n, then it becomes 2 to the n minus 1, which is divided by 2. And divided by 2 is n minus 2. And then this becomes n minus 3. And then all the way down to here, and it becomes a 1. And this one becomes a 0. But for C0, since we don't have any factor, so this becomes a remainder. The first division by 2, the remainder becomes a C0, and then this part becomes a quotient. But each exponent is decreased by 1. So the very first division, we get the least significant position of a binary number, C0, we got it. And then if we do one more time out of the quotient, so this is a quotient, out of the quotient, if we divide it by 2 again, then this is decreased by 1, decreased by 1, decreased by 1, but this is decreased by 1, but here we don't have any decrease. So up to here becomes a quotient, and this becomes a remainder. So remainder, what you get is from least significant bit and so on as we divide by 2 at each time. So as we did 53 divided by 2, quotient and remainder, we have 26 and 1. So we got 1 first division. 26 divided by 2, quotient 13, remainder 0. Then this is C1 will come out. So this is how or why the division method works.